All right, thank you for the introduction, and now for something totally different. My name is Krysta, and I am a scientist. And tonight, the story I'm going to tell you has two parts, and if I give away the ending now, promise not to ruin it. They're both about individual identity. So, I am a cancer biologist. So I mix clear liquids with clear liquids and expect magic to happen to try and understand how cancer works. And it's not easy. Science never is, and I'm sure most of you know that. But the thing is, although we talk about cancer as a single disease, it's actually a multitude of diseases. Now, I'm going to shout out a couple of buzzwords, and if they sound vaguely familiar to you or you have a vague idea about what they are, give me a little cheer. So let's start with precision medicine. Excellent. What about epigenetics? Ooh, bigger than precision medicine. What about diversity? And last but not least, 23andMe. All right, now we can get started. So, I'm going to show you a card trick. Now you have to remember that I'm a scientist and not a magician, so don't expect fancy, flashy tricks. But I took these 9 cards out of a regular card deck. If you look at the back of them, can you tell the difference between any of them? No. But you know that they're probably all different because they came out of a regular deck of cards. Take my word for it, I swear. Now, imagine that each of these cards represents one patient with cancer. If I pull out 4 of these cards and tell you that all 9 given the same drug, these 4 are the only patients who benefited from the drug, how can you tell the difference? Exactly, you can't. From the back, they're all indistinguishable. So we have to know to flip them over to find out what makes them unique. All right, any ideas what makes these ones special? Perfect, they're spades. So this was an easy example because a deck of cards only has 52 items, and there's only a limited set of characteristics to describe them. But as humans, we have 23,000 genes. And a couple of mistakes in a couple of genes can cause cancer. But individuals with cancer don't all have the same mistakes in their genes. Now let's add another layer of complication. All of the cells in your body, from the tip of your finger to the tip of your toe, have the same DNA. What makes one cell know that it belongs to the heart and another cell know that it belongs to the lungs? Excellent, epigenetics. So epigenetics literally means above or on top of genetics. It's another set of instructions that distinguishes one cell from another. And mistakes in epigenetics can also influence cancer. So this brings me to the next question. Precision medicine. I really like how Barack Obama put it when he said, you wouldn't give everyone with a broken arm the same cast, and people who need glasses aren't all wearing the same prescription. What if we could do the same for cancer? And that is precision medicine. So we need to look at what makes a patient's DNA, the DNA of their cancer, different than normal DNA. But there's a big assumption here in that normal is all the same. So that brings me to part 2 of the story, which is who am I? And more broadly, who are you? So I introduced myself and said my name is Krysta and I'm a scientist. As you can probably guess, I identify as a woman, but what you probably can't tell is that I'm also biracial. Is my family represented in what we consider normal DNA? Thank you. Maybe a little bit. So let's just take one example. Most of you have heard of 23andMe. Did you know that 23andMe is best and most accurate at predicting European ancestry than any other ancestry? That's because of the sample. So, science is only as diverse as the scientists who make it up. If I'm not represented in normal DNA, no one can identify very well what makes a tumor in my family different than a tumor in another family. And this is the gap in precision medicine. Thank you.